In this video, we're going to walk through the small sample hypothesis test for mu1 minus mu2. And again, we're going to define a small sample where n1 is less than 30, or we have our n2 as less than 30. And again, we have a couple of conditions required for our small sample inference. So our first condition is that the two samples are randomly selected from an independent manner from the two target populations. Another condition is that both sampled populations have distributions that are approximately normal. And our final condition is that our sigma 1 squared, so sigma squared 1, is equal to sigma squared 2. Now for our different hypothesis tests, we have the same breakdown for hypothesis tests as we have always had. So we have our hypothesis tests for the null hypothesis, for all of them, are the same. So mu1 minus mu2 is equal to a d0 value. And then we have the three different alternative hypotheses, where we have our less than d0 value, we have our not equal to d0 value, and we have our greater than d0 value. And then for each of our hypothesis tests, we have the same test statistic. So we have our t-value, which is equal to our x1 bar minus x2 bar, and all that minus d0, and then divided by the square root of sp squared times 1 over n1 plus 1 over n2. And we use the same formula here for sp squared as we did for our confidence intervals, and that is n1 minus 1 times s1 squared plus n2 minus 2 times s2 squared, and all of that divided by n1 plus n2 minus 2. And then we just had the same rejection region that we've had for all of our t-tests, where we have t is less than negative t alpha, we have absolute value of t is greater than t of alpha over 2, and we have t is greater than t alpha. And then for our degrees of freedom for both of our t values here, for t of alpha and t of alpha over 2, we have n1 plus n2 minus 2 degrees of freedom. So again, same hypothesis test that we've seen before, with the slight variation where we have a new way of calculating our test statistic t based off of the sp squared value, which we also have a formula for. And then after that, we can just walk through the standard hypothesis test that we've done for all the hypothesis tests in the past.